All living things need water. Water is the primary source for all life on Earth to sustain life. It is important to ensure the water and water resources is clean, adequate, and safe to use. Polluted water can bring a great fatal to all living organisms. It is because it might contain toxic substances that could be harmful to living things. Aside from its necessary in living things, water resources also play a big role in economic development and the environment. As water becomes essential to both living things and economic development, rare countries or countries that have too many populations will encounter a big crisis. Water resources might not be adequate for them to fulfill their needs. Thus, wastewater treatment is one of alternatives to encounter this problem. It is important because wastewater treatment is not just limited to the quality of water, but also to ensure the water resources is more than enough for living things and economic developments to survive. Today, many industries use large volume of water in their manufacturing operations. Because of this, some water become contaminated and require treatment before discharge. Wastewater treatment plant is designed to clean sewage and water. These plants remove solids and pollutants, break down organic matter, and restore the oxygen content of the treated water. There are 4 main systems involved in this plant. They are water treatment, water supply, wastewater disposal, and wastewater treatment. In this plant, the most frequently used parameters are biochemical oxygen demand, chemical oxygen demand, total organic carbon, nitrogen, dissolved oxygen, pH, and total solids. These parameters are important to provide a wide variety of information so that the type of contaminated concern can be determined.
I'm Bhavitra Sindhu Venkatesh Parmal to serve you the news of the current update in Renhill SHA Johor Bahru. Here with me are both the engineers of the plant that we have invited for a talk session. Ms. Shamimi as a chemical engineer is responsible to design chemical-based plant with her co-worker Ms. Arina Filza, the design engineer. Both of them has helped the plant to achieve a great improvement based on their designing on the plant water treatment quality after some accident 6 months ago. Congratulations on both of you achieving Excellent Feedback Award on improving the plant. Could you tell us about the improvement based on the processing engineer that you both have done?
So in my part, I have made an installation of a reflux at the water supply system. The main objective here is to further purify the water system. I made a reflux to recycle the water back to the main storage. We applied the closed-loop control system with PID as the controller, FIC, TIC, and ORP, which is the oxidation reduction potential, as the sensor. The ORP sensor is mainly used as the oxygen reduction potential of the solution. ORP sensor is important to water testing because it indicates how sanitized the water based on its oxidation and reduction properties.
Now, we take a look at a closed-loop control system, which is also called as feedback control system. What happens is the new output of the system will depend on the previous output of the system. That is, the system will have one or more feedback loops between its output and input. This means that the closed loop is designed in such a way that it will automatically provide the desired output by comparing it with the actual input. It will generate a signal which is basically the difference between input and the output. The feedback means that the output will be returned back to the input so that we can obtain the desired characteristic that we require. Now let's take a look at the block diagram of the control system. So as we can see here, we have an input which is the error signal, which is the signal between the input and the output, a controller, the process, and sensor. The first step is by measuring it using the sensor. The sensor will measure the control signal, and the process in the physical system that is under control is executing the control process. The output of the plant is adjusted with the error signal. So this is how closed control system will work.
Okay, so PID is just one form of a feedback controller. It is the simplest type of a controller that still uses the past, present, and future error, and its primary features is needed to satisfy our problems. This is why PID is the most prevalent form of feedback control that we have used. Hence, our control strategy on the reflux will look like this.
Thank you, Sulu. This work is not my only work. I cooperate with many engineers and staff at all departments until achieve at this stage. So before this, we have problem with aeration tank where too much foaming until the oxygen level at the bottom of the aeration tank cannot reach the surface. This may affect the problem with microorganisms where microorganisms need sufficient oxygen as their food to run their metabolic activity. As the microorganisms die, they collide and stick together and then result to what is called flux.
So, to reduce the flux forming, what I propose is inserted the proportional integral controller at the input aeration tank and attach it with composition analyzer, that is gas chromatography sensor. The proportional integral function as give error signal to the sensor, which is that gas chromatography, in calculating the oxygen level in the aeration tank. The control strategy for this first PI controller is straightforward, cause we want measure the disturbance with that oxygen level directly and take control action to eliminate its impact on the process output. I also applied PI controller at the effluent of aeration tank to measure the plant performance by measure the nitrate concentration in the process, because it will involve in the sludge removal. More sludge produced, more organic matter is removed by water. The control strategy for this improvement is feedback, cause we taking action at the effluent to adjust the value at the manipulated variable.
So, I heard you have implemented an improvement on your chlorination process because some has said that the chlorine is released not according to standard. In which part of it?
Yes, we did. I designed a fuzzy scheduling system in our chlorination tank. The objective is to measure the chlorine demand needed for the water to purify. In case it needs a high amount of chlorine or low amount of chlorine to successfully destroy microorganisms. So this is how it goes.
So this is an example of a block diagram of the control implemented for the tank. Fuzzy supervisor controls a block of variable gains, which is used as the input for the PI control. On the other hand, it also controls a feed-forward block that creates two outputs in addition to the PI controller's control signal. The fuzzy supervisor input variables are temperature, chlorine in the mixing chamber, the RO flow rates, and the granular activated carbon filters. The gains of the PI controller for the four described operating points were computed, depending on the temperature in the mixing chamber and the water distribution between flow rate and the carbon filters. And this is how our design looks. A flow rate sensor is placed in between the pump and the tank. The input variable of this circumstance is the flow rate of water pumped from the pump.
while the manipulated variable could be the opening or closing of the valve located before water entering the tank. The fuzzy supervisor is also installed with chlorine sensor to keep the chlorine in control. Based on the improvement PNID, the gains of the PI controller for the 4 described operating points can be computed depending on the temperature in the mixing chamber and the water distribution between RO and FCAG. Hence, we can keep our chlorination level in check.
Water distribution is usually related with zinc, iron, pH water and so on. Few past years ago, the product from SAJ has been denied because it does not follow the minimum requirement before the distribution. So what did you do to gain back the trust of your consumer to your company?
Okay, but the pH you mentioned, we learned our mistake and did many research on how the water still contain hydrogen ion in water, although the water is run in the water treatment process. So we rely, instead of we added another treatment or plant, so to purify more water quality. Generally, the performance of biological treatment is divided into 3 stages: primary, secondary, and tertiary or advanced treatment. SAJ has only 2 sedimentation tank, where primary and secondary. So I recommend to the company. To insert the pH indicator at the secondary sedimentation tank.
pH indicator act as sensor to measure the acidity or basicity of the pH value in the secondary sedimentation tank treatment. If water is too much contain high hydrogen ion in the water, the proportional integral derivative controller that attached with the pH indicator will give the signal to the pump dosage to release set concentration of base chemical solution to pump into the tank. So the treatment process is only involved in that secondary sedimentation part only. So in this improvement, the control strategy is a feedback control configuration in which the output variable, which is the concentration of organic matter, is controlled, are measured by a pH indicator controller to measure the value of the manipulated variable.
Thanks to Engineer Nur Shamimi Halim and Engineer Nur Arena Filza Sarbani for their comments just now regarding the accident that happened. That are the improvements that has been planned by them and will be adopted to avoid any accidents later. Indeed, the people hope that such accidents will not happen again in the future. That's all from me, Bhavitra Sindhu Venkatesh Burma. Thank you.